Okay, guys, hi, welcome back. So, in this video, we will discuss the Coulomb's law, and this is a very important topic of this chapter. Okay, so first, let us see what is the statement of Coulomb's law. So, Coulomb, he stated that the electrostatic force of attraction or repulsion, okay, between two point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them and acts along the line joining the two point charges. So, what it states that the force can be either attractive or repulsive between 2 point charges, right? 2 point charges can have either attractive force or repulsive force. If they are having like charges, then they will have repulsive force, right? If they are unlike charges, then they will have attractive force. So that particular force is proportional to the product of what? Magnitude. And it is directly proportional to the product of magnitude of charges. And it is inversely proportional to the separation between the two charges. And this force will act along which direction? Along the line joining the two charges. Suppose if I consider here to be charge Q1 and the other charge to be Q2. Okay. If I'm considering this to be positive, this to be negative. So they will have an attractive force. Okay. So if I consider, just a second. So if I consider in this particular case, the distance between these two charges to be R. Okay. The distance between these two charges is what? R. Okay. I'm considering this to be one to be positive and other to be negative. So the force between them is attractive. So if it would be what? One would be positive, the other would be positive, then the force would be what? Repulsive. So it's completely on you, whether you consider it's attractive or repulsive, because you need just the magnitude of the charges. Okay. So here the first thing what it is said, the electrostatic force Fe, I'm denoting it with Fe. It is directly proportional to the product of what? Product of the magnitude of the two charges. So this is the magnitude of the two charges and it is directly proportional. And second, what it is said, it is inversely proportional to the distance between them. Okay, to the square of the distance between them. So R is the distance between the two charges. Okay, and its square is proportional. Okay, now when you will combine both these equations, okay, combining, okay, combining, this is equation 1, suppose, and this is equation 2. Combining 1 and 2, what you will write? The electrostatic force is what? Proportional to Q1 by Q2 by R square. Now, when you will remove the proportional symbol, what you will have? Fe is equals to K Q1 Q2 by and it is what? The constant electrostatic force constant. Clear? So this is K. So this is the Coulomb's law. This is mathematically the Coulomb's law, which I'm writing here again. It is equals to K Q1 Q2. This is the magnitude by R square. Okay. So this is the Coulomb's law. I think this is clear. Next, what we will see that this K is equals to what? Okay, what is this K? The electrostatic force constant, it is equals to what? That we will see. All right. And now you see this K. This K can be written as K is equals to what? 9 into 10 to the power 9 Newton meter square by Coulomb square. Okay. So this is the value of K. Clear? This is the value of K. Now you see K can be written as K is equals to what? 1 by 4 pi epsilon naught. Here epsilon naught is what? It is the permittivity of free space. Is the permittivity of free space. Clear? and its value will be equals to 8.854 into 10 to the power 9. K is what? So what you can write here, it will be what? Coulomb square by Newton meter square. This is what you can write, okay? By Newton meter square. So this is the unit. Clear? So this epsilon naught is the permittivity of free space. And in this case, we can say free space of vacuum or air, all we have taken to be same. So this formula which we have seen, okay, that Fe, the electrostatic force, is what? 1 by 4 pi epsilon naught. Here you are having Q1, okay, Q2 by R square, or what you can write, Fe, it is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Clear? This can be used only in those cases when the medium is what? Free space, vacuum, or air. Now we will see what is this epsilon naught and what does this epsilon naught permittivity means. Okay, permittivity is the quantity that will determine how far a medium will permit the electrical interaction between two charged bodies. Okay, so here it is the definition. Permittivity is the quantity that determines how far the medium permits the electrical interaction between two charged bodies. Okay, suppose just now we have seen that this is a body Q1, charge body Q1, this is the charge body Q2, and the distance between them is what? R. The separation between them is R. So the force is acting along the line joining these two charges, right? So in this case, if you see, permittivity is what? It will, it is suppose the medium between these two charges is what? Vacuum. Okay, so if the medium is vacuum, so here you can see from here that this permittivity, when permittivity is what? More, the force, electrostatic force will be less. Okay, when permittivity is what? Less, electrostatic force is what? More. So in case of vacuum, if you see, the permittivity is very less, because when there is no medium, okay, so because if there will be some medium that will permit what, how much force will be there between these two charges here. Okay, so if your permittivity is very small, then what will happen? If it is allowing it, if it is permitting more force within itself, then obviously there will be less force if your permittivity is more. Okay, if suppose for any medium, if you are having that the medium is permitting what? More force within itself, then obviously the force on the other charge will be less, right? Because if because from this equation also you can see, if the permittivity is more, the force will be what? Less. So the same thing goes if you are having any medium. In case of vacuum, the permittivity is very less, so the force is what? More. And if the permittivity is less, the force will be more. Okay, so from here you can say that permittivity is nothing but it is that quantity, it will determine how far the medium will permit the electrical interaction between the two bodies. Clear? I hope this is very clear to all of you. Next we will see a few more things related to this. So till here I think we don't have discussed anything very complicated. Okay, now we will just see what is 1 coulomb. How can you define 1 coulomb? Okay, suppose if you consider, if Q1 is equals to Q2 is equals to 1 coulomb. Okay, and 1 by 4 pi epsilon naught. This 1 by 4 pi epsilon naught is equals to what? 9 into 10 to the power 9. Okay. Then what you can write, the electrostatic force Fe, it is equals to what? 9 into 10 to the power 9. Okay. And R, the separation between them, you have to take 1 meter. Okay. Then in that case, you will have what? 1 into with 1 by how much? 1 square. How much you will write here in this case? This is 1 square. Just I have taken that Q1 and Q2, the value of the two charges is equal and same. Okay. 1 by the value of K. Okay. K is equals to 1 by 4 pi epsilon naught. It is 9 into 10 to the power 9. And the separation between the two charges I have taken 1 meter. So I can write the electrostatic force Fe is equals to what? 9 into 10 to the power 9. So you can say that when, okay, the two charge bodies are separated by unit distance and they have force how much? 9 into 10 to the power 9 Newton. Then you can say how much charge is there? It's 1 Coulomb charge. Okay, 1 Coulomb charge is defined when the force between two charges is how much? It is 9 into 10 to the power 9 Newton. And when they are separated by how much distance? Unit distance. Clear? So this is 1 Coulomb definition. I hope this is clear. Next, we will see a few more things. Okay, this is permittivity. So for permittivity, we have already seen certain things. So we will see the dimension of the permittivity. Okay, so before that, we will see first the dimension and unit. Unit, obviously, we have discussed only. Unit and what we will see, dimension of K. First, we will see the unit of K and then I. We have seen F is equals to how much? K Q1 Q2 by how much? It was R square, right? This was what it was. So you can write from here K is equals to how much? F R square by Q1 Q2. So that can be written as, for force the unit is Newton, right? R is the distance, so it's meter square. And for charge you will have Coulomb square. So this is the unit for what? K, right? Similarly, you can write the unit of what I'm writing here. Unit of what? Epsilon naught. That will be what? Obviously reverse, because you know K is equals to what? 1 by 4 pi epsilon naught. So the unit will be just reverse. What it will be? It will be Coulomb square. Okay, Coulomb square by Newton meter square. Clear? This is what it is. Just the reciprocal. You can write this to be as, this unit you can write as Newton meter square Coulomb inverse square. And this you can write Coulomb square Newton inverse meter square inverse. Done. Now we will see the dimension of K. So for the dimension of K, it's very obvious. You can write what? Dimension you can write as, this is the dimension. So dimension of K will be equals to how much? K is equals to, for force, you know the dimension is M L T minus 2, right? What you will write? T minus 2. Just a second. T minus 2. Okay. This is for meter, which is length. So it is L2. And in the denominator, for charge, you know, the dimension we have already calculated, it is AT, right? Here is a square. So it will be what? 2 times you will just write AT, AT. So from here, you can write the dimension of K to be, K is the electrostatic force constant. Okay, for it is what? M, L will be how much? 3. T you will write minus 4, right? This is what you will have. And here for A, you will have what? Minus 2. I think it's clear. No doubt. So this is the dimension of electrostatic force constant. Similarly, you can calculate for what? For permittivity. Similarly, you can just write the reciprocal also, because we know K is equals to 1 by 4 pi epsilon naught, right? And we have written K was equals to how much? From here, F is equals to Q1, Q2, K by R square. Okay, so from here, F is equals to what? 1 by 4 pi epsilon naught. This is Q1, Q2 by R square, right? From here, this 1 by 4 pi, this is constant term, so this is not required. Epsilon naught is equals to what? Q1, Q2 by F R square. So for this case, directly you can write for epsilon naught, what you will write? Coulomb, because this is what? For charge, it is what? Coulomb square, na? This was what? So directly I'm writing the dimension, okay? It is 80 into with how much? 80. Clear? And here what you will have? ML T minus 2. For force, the dimension is so, and this is L square. So finally, what you will write? Epsilon naught is what? A square. T, what it will be? This is minus 2, it will go here in the numerator, it will be plus. So T to the power 4, right? m with a negative m minus 1, and lastly what you're having L minus 3. That means you can write epsilon naught dimension is what? M minus 1, L minus 3, T positive 4, A positive 2. So if you see for this, here it was M was positive, L was positive, rest 2 and negative. Here it goes the reverse. These two are what? Negative, and the last two are positive. Clear? The same thing will be there, and directly you can calculate it from the unit itself. Okay. If you're having problem, you can directly calculate it from the unit. Done. And these units which you have calculated, these are the SI units. Okay. What it is? This is the SI unit. These are what? SI unit. I hope so this is clear. All right. Next, let's see the characteristics of Coulomb's law. What are the characteristics of Coulomb's law? So the first characteristics of Coulomb's law is what? It is applicable, or you can say it is valid only for point charges, okay, which are at rest. If you are having point charges and the point charges are at rest, then you will apply the Coulomb's law. Second is it is obeying the inverse squared law, okay, because it is directly proportional to 1 by inversely proportional to what? Force also, because in case of gravitational force also, you know, it is equals to what? M1 M2 by R square. You are having the G M1 M2 by R square, right? This gravitational force Fg is equals to what? G M1 M2 by R square. So this is a similarity also, that both Coulomb's and gravitational force are applying, are using what? The inverse square law. So it is a long range force. Okay, it is a long range force. This is also a very important characteristics. Next, if Coulomb law will be not active, okay, it is inactive when the separation between the charges is less than 1 Fermi. 1 Fermi means how much? 10 to the power minus 15 meter. Okay, if this charges, okay, the two charge bodies are if at a distance less than 1 Fermi, then there will be no Coulomb's law. Clear? Next, you know, it is a central force because the force is acting along the line joining the two centers, because we have seen already in the definition also this, and it is obeying the Newton's third law of motion. This we will see in Coulomb's vector form, that how it is obeying the third law. But for now, you remember that Coulomb's law obeys the Newton's third law of motion. Next, it is that it is depending on the media within which charges are placed. Yes, because of the permittivity, if the medium is changing, obviously the electrostatic interaction between the point charges will also change. So it will depend on the medium. And now whatever formula we have written, that is only for vacuum, air, or free space. And the very last point is what? Coulomb's law, it is not affected by the presence of other charged bodies near it. Okay. So if you are placing any other charged bodies near the two charged bodies, then there will be no change in the Coulomb's law. Okay. So I think this is very clear. First, it is for what? Point charges at rest. It is obeying the inverse square law. Long range force. The separation, at least it must be what? It must not be less than 10 to the power minus 15 meter, which is 1 Fermi. Okay. Force will act always along the centers of the two, the line joining the centers of the two bodies. That means it is a central force. It is what? It is obeying the Newton's third law of motion. And then what you saw, if the medium changes, the electrostatic, the Coulomb force will also what? Change. Means it is depending on the medium. And if you are placing any other charge bodies near the two charge bodies, then Coulomb's law will not change. Clear? So that's all in this video. I hope this is very clear and it was easy. Thank you so much. Have a good day.